This is the homework help video for Advanced Algebra Lesson 4-2, Operations with Matrices. First problem we're going to look at is problem number 14. You are to add these two matrices if possible. So the first thing you want to look at is the dimensions. This first matrix, the one on the left, that has 3 rows and 1 column. The second matrix also has 3 rows and 1 column. Since the dimensions are the same, you are able to add these two matrices together. Your answer matrix will also be 3 rows, 1 column. What you do is you add elements that are in the same location. For instance, the number 4 is in row 1, column 1. That gets added to 6, which is also in row 1, column 1. 4 plus 6 is 10, which goes in row 1, column 1. And I continue that same pattern. Row 2, column 1, plus row 2, column 1. 1 plus -5, -4 goes in row 2, column 1. And finally, row 3, column 1, plus row 3, column 1. -3 plus 8 is 5. And I have my answer matrix. The next problem is problem number 18. For problem number 18, you have scalar multiplication in addition to addition. And what that means is you have this 5 on the outside of a matrix, and you have the 3. Each element in the matrix has to get multiplied by the 5 in the first and the 3 in the second. So if I multiply every element in the first matrix by 5, 5 times 0, 5 times -1, 5 times 7, and 5 times 2. That is my new first matrix. That will be added to 3 times the second matrix. 3 times every element in that second matrix. 3 times 5 is the 15. 3 times the -8, -24. 3 times 10, 30. 3 times -4 is -12. What I should have done before anything else is, again, check my dimensions. For the first one, it has 1 row and 4 columns. 1 by 4. Second matrix has 1 row, 4 columns. Dimensions are the same, so I can add these two together. My answer matrix will also be a 1 by 4. 1 row, 4 column matrix. Just like in the previous problem now, I will add elements in the same position together. Row 1, column 1, plus row 1, column 1. 0 plus 15, there's row 1, column 1 in my answer matrix. -5 plus -24. Row 1, column 2. 35 plus 30. Row 1, column 3. And finally, 10 plus the -12. 10 plus -12, -2. I have my answer matrix, which also is 1 by 4. Next problem would be problem number 27. Similar to the other 2 problems, but they didn't put the matrices in the actual problem. They gave you a list of them, A, B, C, and D, and asked you to perform the operations on those 4 matrices. 27 is 6b minus 2a. Before anything else, I take a look at the dimensions. Matrix A, my dimensions are 3 rows, 2 columns. Matrix B, 3 rows, 2 columns. Dimensions are the same, I can perform my operation. I notice I have a 6 out in front of the B. Again, scalar multiplication, every element in matrix B will get multiplied by 6. So in reality, my first matrix will be 48 and 18 for row 1. Row 2 will be 30 and 6, because I'm multiplying 6 times 5, 6 times 1. And row 3 will be 24 and 24. The second half of the operation says 2a. That means 2 times matrix A. Every element in matrix A gets multiplied by 2. So row 1 will really be 10 and 14. Row 2 will really be negative 2 and 12. Row 3 is going to be 6 and negative 18. I now perform my subtraction. Elements in the same row and column will be subtracted. Row 1, column 1, the 48 minus row 1, column 1, the 10. 48 minus 10, 38 goes in my row 1, column 1 answer matrix. And I continue that same pattern. 18 minus 14, row 1, column 2. 30 minus negative 2, row 2, column 1. 6 minus 12, row 3. 24 minus 6, row 3, column 1. And finally, 24 minus negative 18, which gives me a grand total of 42. I do my scalar multiplication first, and then I do the subtraction. Final problem is number 30. It's a story problem about the bakery. They want you to write a matrix for each day's sales. You're writing a matrix for Friday, you're writing a matrix for Saturday. You have the spreadsheet in your book for number 30. That spreadsheet is just being transferred to a matrix. So I see column B says chocolate chip with the 120, the 80, and the 72. Those numbers are going into a matrix in that column. I do the same thing for row C for peanut butter. 97, 59, and 84. Sugar and cut out the same. 64, 36, 29, and the cutout 75, 60, and 48. Depending on your teacher, they may want you to label this. This is the matrix for Friday. Sometimes you may want to label your rows and columns. Like this is store 1, store 2, store 3. First column was for chocolate chip. Column 2, peanut butter. Column 3, sugar. And column 4, cutout. Your teacher may not want you to do that. You may need to when you perform your matrix operation so you know what each column and row is actually standing for. And I could do the same thing now for Saturday. I could take that table from the book, that spreadsheet, and just rewrite it in a matrix. I now can answer question number 31, find the sum. Answer number 32, find the difference by using these two matrices.